So one of the compounds that you are asked to recognize when you see one is an ester. And in our esters, what we're going to do is it's very similar to carboxylic acid, but we're going to take the H off of the carboxylic acid and replace it with a carbon group. So the example that I have on the screen, I've replaced the H with a methyl group. Because if this were a hydrogen, it would be called formic acid, okay? If we were to replace that H with a methyl group, the way it's named is methyl for that part, and instead of getting the ic acid ending, it gets the ate ending. So this is methyl formate, methyl formate. And you're going to recognize when you're looking at labels of things, you're going to recognize that you're dealing with an ester because you're going to see that ate ending in there. It's going to have two words associated with it, and the first word is always what comes after the oxygen of that ester group. All right, so here would be the simplest one, methyl formate. You have to have a C here, so you have to have at least a methyl group here. You don't have to have anything over here besides an H. In this case, this is methyl formate. I've already stated that. I don't know why I have it up there again. So we're replacing that H group with a carbon atom. Now, I am not going to go into you having to be able to name these compounds. However, you're going to be doing a label search and you're going to be looking for compounds, and you're going to need to recognize an ester. So if you see the name, you should probably be able to recognize that you're dealing with an ester, and I've kind of gone through in the first slide how this is done. So you're going to no longer have the ic acid ending, but you're going to have an ate ending, and that's going to be a good giveaway that you're dealing with an ester. So if we were to replace the formic acid with a acetic acid has a CH3 here. So instead of being formic acid, it'd be acetic acid if this were an H. Okay, so that's acetic acid. So we're going to replace the H with a methyl group. Okay, no, we're not. We're going to Yes, we're going to do that on both sides. So we're going to replace this one with another. Instead of having a methyl group, we're going to have an ethyl group. Okay, so this would be ethyl acetate instead of methyl formate. Ethyl acetate. So we see we have two carbons here. That's the acetic acid part. And we have two carbons here. That is the ethyl part. Now, what do we associate esters with? Esters have a very nice smell. Very often fruits have got esters in it. Okay, esters can readily evaporate. That's what we mean by volatile. We don't mean it's going to blow up. Volatile means it can go into the gas phase fairly easily. So a lot of times esters, because they don't have an OH group that holds them together, they can readily evaporate. If they're readily evaporating, they can get to our nose, they can dissolve in the moisture in our nose, and we associate that with a good smell. Well, because of the way they are, those have good smells, okay? Now, I don't want you to memorize this, but I want you to familiarize yourself with this because you might run across some of these chemical compounds when you are doing your label search. So let's look at these, okay? Notice a lot of these are fruits: apples, apricots, pineapples, oranges, bananas. These are the odors that we associate when we smell these esters. So this is the one place where if you go into a laboratory and somebody says, smell this, and you waft it over you and say, that smells good, it is probably an ester. So you can see the names and the compounds associated with it. If it's two carbons before the double bond, that O, this is the double bond on this oxygen in there. So we've got that happening in that spot. That is the acetate part, okay? That's the acetate part of it. And then everything that's coming after that, notice in this compound, it says octyl. Oct is 8. So there's going to be 1, 2, 3, 4, 5. Let me do it with my hand here. 1, 2, 3, 4, 5, 6, 7, 8 carbons associated with it. So the name really describes what you're looking at. I want you to know that esters are associated with pleasant aromas. Now, if the carbon chains get really, really long, these form beeswaxes, okay? Beeswax would be an example. We could see them being used in makeups So they're long chain esters. They're long chains on both sides. So you could have a very long chain. I'll let this represent a long chain, and the C, the double bond, and then the O, and then another very long chain of carbons. Okay, these are the kinds of things that are your waxes. In beeswax, it says here that we are going to have between 24 and 36 carbons on those. And that would be the end of it that has a C double bond O and then the O, and then you could have some more carbons on the other side. So no, that's not what I mean. We're going to learn how to join alcohol and a carboxylic acid together in class with an activity. So you're going to take a carboxylic acid, you're going to take an alcohol, you're going to pull water out, and they're going to join together. So your beeswaxes, what you have is a carboxylic acid with up to 36 carbons, and the alcohol from 24 to 36. So these chains are 24 to 36 carbons long on either side of that C double bond O group in the middle there. Okay, so your lipsticks very often will contain waxes and oils. Emulsifiers, which are things that are going to hold nonpolar and polar compounds together. Of course, they're going to have synthetic dyes to give it color. The oil that's most commonly found in lipsticks, just so you know, is castor oils. And that's what's going to keep your lips moist in the course of wearing lipstick, for all of those you wanted to know. Okay, so that's what I want you to know about esters. We will spend time in class actually practicing making esters. And I don't mean really making esters. I mean learning how to, on paper, join them together. When you have an alcohol and you have a carboxylic acid and you want to put them together. When you're doing the label search in our class, esters might show up quite often because they are used to give a lot of the things that we use good odors, good smells, good taste, good flavors. All right, so that's the end of this lesson on esters, and we'll, like I said, practice with this when we get into class.